Hello and welcome once again to the Maths Jedi channel. This is another video in my A-level lessons series, and this particular video will be talking about two-tailed testing. If you didn't watch my last video on hypothesis testing, definitely you should watch that first because this follows straight on from that. And then previously to that previous video, we've got a whole series of stuff on binomial distributions, which will also feature today. So if you haven't caught any of my other videos, please do catch those. If you're new to my channel, welcome. I hope you can subscribe. Please do leave a like, that would be really helpful and it will support the channel, so that will help me out a ton. If you're not new and you're used to it by now, you'll know that I like to get straight on. So without further ado, let's just kick on straight into this PowerPoint. Just look a little bit at these different features of two-tailed testing and why it's different from one-tailed testing, which we looked at last time. So the first thing to recognize is with one-sided testing and two-sided testing is that there are definite things that differ between those two different types of situation. The first thing to mention is that all the tests we did in the previous video were one-tailed testing, basically talking about whether things were increasing or decreasing. So that was one-tailed testing. Two-sided testing is when parameters just change. So you're not told whether they increase or decrease, you're just looking for a change. Now we talked a little bit about null hypotheses and alternative hypotheses on the previous video. A feature of two-tailed testing is that the null hypothesis will always be looking at a particular parameter, and the alternative hypothesis will look at whether that parameter has changed. It's usually something like a not equals to sign that you'll see, as opposed to a more than or less than symbol that we used last time. The important thing to mention is that with significance levels, as we mentioned last video, so for example 10% or 5%, you're always using half as much for two-tailed testing. So you're looking for both sides of the distribution, the upper side and a lower side. Here's a good example. So just to start off, we'll do an example in here and then we'll head off into the books, much like last time. This particular example is talking about a restaurant finding that 60% of its customers have been pleased or very pleased. A new chef is appointed and the restaurant management wish to find out whether this has changed. So the key word there is changed, not whether it's gone up, not whether it's gone down, but they're looking for a change in the proportion. That's what tells you that this is a two-tailed testing question. He's questioning 16 diners and recognizing that 14 of them are pleased or very pleased with their food, and they want to see at a 5% significance level whether there's been a change in proportion of contented customers. So the first thing to mention is that with 5% significance level, you're going to halve this. So you're looking at the 2.5% at the beginning of the distribution and the 2.5% at the end of the distribution, and they will define your critical regions. So in terms of stating the hypothesis, as I mentioned, you'll have a null hypothesis, which would be 0.6. 0.6 comes from the 60% on the previous slide, so 60%, that's where the 0.6 comes from. And then the alternative hypothesis will be that it's not 0.6. There's a change in a proportion. I mentioned about the 5% significance level and halving that, so we will halve that and have a look at what it does. Focusing in on the binomial distribution size 16 and then the probability of success 0.6, size 16 because that was his sample size. He questioned 16 diners. We're going to look at more than 14 because we're looking at the latter half of the distribution, primarily because we know that it's at the latter half. As it's mentioning here, 16 times 0.6, so if we're expecting 16%, we'd be expecting around 10. So 14 is at the latter half of the distribution, so we're looking for the upper tail in terms of its testing. So we're going to look at the calculation of more than or equal to 14. Now you can use tables for this. We can look at the probability of it being less than or equal to 13 and then take that away from 1. And they actually do work it out. So they actually do work out how the probabilities work from 14, 15 to 16. So you could do that. You could also use a calculator, of course, which I have showed on previous videos to work it out. Eventually they do get the cumulative probability as being 0.0183, and that's less than 2.5%. So this is lying in the critical region. And if it's lying in the critical region, they can reject the null hypothesis. Here's another example. A driving instructor knows from past experience that 2 out of his 3 students pass their driving test first time. They want to see whether the instructor has changed the proportion. So again, two-tailed test. He monitors next 12, 6 pass first time around. Write down a suitable null and alternative hypothesis. Explain why alternative hypothesis has the form it has. So it's a very simple. Null hypothesis will be it will be 2/3, and then the alternative hypothesis will be that it's not 2/3. The 10% alternative will have to be halves. It's 5% for each tail. We're looking at a distribution 12 with 2/3 because 12 was the number in the sample that he took. And then if you're expecting 8 candidates to pass, because obviously that's 2/3 of 12, we know 6 is at the lower end. So we're looking at the lower end of the distribution this time. So if we're looking at the lower end, we're looking at the cumulative probability of it being less than or equal to 6. You can look that up on the tables or work it out from a calculator, and you'll get 0.1777. That's more than 5%. And so this time, as opposed to the last time, we're not rejecting the null hypothesis. We're just going to have to say that at this point, we haven't got enough evidence. Okay, time to go into some questions. Let's have a look at some questions. We're going to focus in on a couple of things here. I'm going to start off in exercise 7b. I'm going to focus in on question 6 and then question 9. So those two questions here. So question 6 and then question 9. So we'll look at those real quick. And it says a random variable has distribution 10, p. A single observation is used to test h0. P equals 0.22, and against P1, the alternative hypothesis being that P is not 0.22. So again, two-tailed testing. It's asking me to use a 1% level of significance. So we're going to be doing that with a 1% level of significance. That means on either side we're looking for a 0.05 chance. So 0.5% each side. And we're being asked to say the probability in each tail should be as close as possible to 0.05. So that's the key thing here, that in this particular example, we're looking for the probability to be as close to 0.05 as possible. So what we need to be doing is, first of all, modelling our binomial distribution. We know our null and alternative hypothesis already. So our null hypothesis, H0, was the fact that P is 0.22. Our alternative hypothesis, H1, is that P is not 0.22. And we're being asked to model that as a distribution. It's a binomial distribution, size 10, probability 0.22. The probability in each tail needs to be as close as possible to 0.05. We won't be able to look this up on the tables, it's just not possible to do that. So we're going to need to work some things out, make sure we've got an understanding about where these values lie. Now again, as with last time, we can use our calculator to our advantage here. And as with last time, we're going to use our old friend mode 7. So I'm going to go into there, mode 7, this one here, binomial CD. We're going to go into list mode this time, so we have used that a little bit more in the last few videos, so we're going to use that a bit more today. And because we're being asked for 10, we're going to look at all the possibilities. Because we've got a size 10, we're going to put in some probabilities here. So I want to look at all of them. So I'm going to look at some of them to help with, to start with. So I'm going to put 0 in. I'm going to put 1 in. Let's look at the whole distribution as a whole. 2, 3, 4, 5. We can put the whole lot in because it's quite small. 7, 8, 9, and 10. Distribution will be 10 and 0.22. Press equals. Okay, so there's quite a lot going on here. We need to be very careful about it. Because we're asking the question to find, I'll just remind you again, to find the chances as close as possible. That's worth bearing in mind. So I'll just move that to one side and remind you of that. So it's asking you to say the probability in each tail should be as close as possible to 0.05. So that's quite interesting. They've stated that in the question. So you can see straight away my first region, my value of 0 is producing a probability of 0.0833. I think that says. You can use the calculator to find that exact value if you want to. So 8335 in this example. So I will just slightly round it up just to take that into consideration. So that's what it is to 3 SFs. And then we're going to look down the calculator to find our other critical region. Now again, we're looking at a critical region which is more than 0.005. So we're looking for 1 minus that figure, 0.995. So we're looking for 0.995, or as close around to that point as possible. Okay, so just a reminder where that came from. I did 1 minus 0.005, and I looked at this, I was looking at this. We're looking to see this in our calculator now for the upper end of the distribution. Let's see if we can find that. So none of these count, so we're going to go down the list a little bit. And you can see we've got a range of a cluster of values here that sort of fit into that. So we're gonna look at that real careful. Just take into account what each one is. So we'll start with the one that's less than or equal to 5. So let's look at that. So probability of it being x less than or equal to 5 is going to be 0.9896. And probability of it being less than or equal to 6 is 0.9984. Okay, so those are the two possibilities I want to look at. I'm going to rub out the rest, so I've got more room to work. And what we're going to do is we're going to look at what happens when we take those values away from 1, because that's important. So a reminder about what probability says in this regard. So we're looking at the upper half of the distributions. Just a reminder that those probabilities that are more than or equal to 6, so more than 6, will be 1 minus probability of it being less than or equal to 5. So that's important. So more than or equal to 6 is 1 minus this one, 1 minus 0.9896. And we're going to work out what that is. I'm just going to run the rest away here for a little bit. So we're going to use the calculator for that. So I need to go back into calculate mode, mode 1. So 1 minus 0.9896. And we're getting 0.0104. And then we're going to do the second one as well. So probability of it being more than or equal to 7 is 1 minus probability of it being less than or equal to 6. And so that's going to be 1 minus 0.9984. So we're going to calculate that one as well. So 1 minus 0.9984, that's this. So it's a very small number. 0.016, very small. So which one of these is more than 0.005? So this one's 0.005. This one's quite far away from 0.005. This one's relatively close to 0.005 compared to that one. So this one is the closer one. It's the one that's more than 7. So in terms of a critical region, if you go back to the question, it's asking for a critical region. There are 2 critical regions because it's a two-tailed test. It's everything that's equal to 0. So we had that from earlier, if you remember. So the value that where x is equal to 0. And then everything that's between 7 and 10. So everything between 7 and 10. It has to be between 7 and 10 because, of course, 10 is the uppermost value that you can have. And we're looking always at the probabilities to get through that. Because we're looking at cumulative distribution, we are looking at it being between 7 and 10, but it could be that 7's in the critical region itself. So we are going to highlight that, and we are going to highlight that, because it could be as much as 10, it could be as little as 7. So we are going to look at a critical region between 7 and 10. We can state the value of it equal to 0, simply because that was the value we picked out, and even on the cumulative distribution chart, we can read out that x equals 0 is the exact probability. A reminder though, that in terms of the question, because the question does touch on this, I'll leave this live a little bit. The question does say, if you read it, write down the actual significance level of the test. So earlier on we worked out the probability of it being naught. The probability of it being naught was 0.0833. The probability of it being between 7 and 10 was 0.0016. So we're going to add these two possibilities up. And if we add these two possibilities up, we will get the combined significance level of the test. So again, calculate mode, I'm already in, so just add on 0.0833. And that gives me 0.085. I'll do it to 2 SFs just to avoid a rounding error. So 0.085, so that's about 8.5% significance. Okay, so slightly more than the 1% we needed, unfortunately. That's just because of the inaccuracy of the lower bound. So let's just go through the stages of that question and monitor what we were doing. We stated a H0, we stated a H1. Notice how it's a two-tailed test here. We were doing a 1% significance level. We halved that. We were looking at probabilities near to or as close to as 0.005 as we could get. And the actual significance level, we added up the two ends probabilities to get that total correct. Let's crack on now through clear my annotations and work through on number 9. I wanted to give you a word of caution while I'm at it that the answers to this particular exercise are a little bit incorrect. There's some errors in it, so just be aware that the answer sheets for these are incorrect, but the answers at the back of the book are correct. So please be aware the answers at the back of the book for this exercise are correct, but the answers in the answer sheets are not. So just a reminder just to take extra caution when you're looking through this exercise, because that can definitely cause you a few problems. So number 9 we're going to work our way through. It's talking about a restaurant owner noticing that her customers typically choose lasagna 1/5 of the time. She changes the recipe and believes this will change the proportion of customers choosing lasagna. Suggest a model. Model is going to be binomial, constant proportion, doesn't change, independent events, etc. Previous videos do illustrate that quite well. So binomial distribution for sure. We're going to be taking a random sample of 25 customers in a moment. A probability of it being a fifth, 0.2. That's what our binomial distribution is going to be. Our null and alternative hypothesis will be that the proportion stays the same, 0.2. And our alternative hypothesis will be that it doesn't stay the same, it's changed, it's something other than 0.2. We're going to test that value out at a 5% level of significance. So 5% level of significance, either side, will be 2.5%. That's 0.025 that we're looking for our critical regions. So we're going to work our way through the critical regions and understand that we're trying to find the overall probability being as close to as 0.05 as we can get. We'll bear that in mind for later on, but we're going to work our way through this. Now for this particular question, I'm going to use the tables this time, so I'm not going to use the calculator. 25 is quite a large value, so I'm going to use the tables, and to be honest, with most two-tailed distributions, you're going to find the tables can be quite useful for this. So here are the tables. Here's the size 25. This is the probability I need, 0.2. We're going to look down our list and find the different probabilities that are perhaps relevant for us. So remember, I'm looking for a value that's near to or as close to as 0.025 as we can get. Okay, previous question did talk about as getting close to as possible, and so does this one. So we don't mind if we're slightly over. That's worth bearing in mind. With this particular question, we're looking down the list for 0.02. You can see, first of all, probability of 0 is 0.038. So that's relatively close, and then 0.0274, again relatively close, but this one is obviously much closer than this one, so it's probability of it being 1 that we're going to look for here. So the lower end of my critical region will be anything less than 1, because this is very close to 0.025, much closer than that. So this has to be the value we're looking for. And at the upper end, we're looking for 1 minus 0.025. So we're looking for the values that are going to be at the upper end. So again, you could use your calculator to work out what that is and just give you a little marker as to where you should be looking. So we're looking at 0.975 here. So I'm looking down this list here to see where 0.975. So these are the two values I'm going to look at, 8 and 9. So just sort of circle those for you. So 8 and 9. Okay, so first of all, let's just work and focus through with 8 and 9 and understand what's going on. So with 9 particularly, the probability of it being less than or equal to 9 is going to be 0.9827. So the probability of it being more than or equal to 10 will be 1 minus this, 1 minus 0.9827. Okay, so that's a bit similar to last time. If I rub this out, it gives me a bit more space to write because I'm not sure it's coming out too well. Okay, and then the second one here, probability of it being less than 8, less than or equal to 8, is 0.9532. So probability of it being more than or equal to 9 will be 1 minus this 0.9532. So we can use our calculator to work out those two values, just to have a look at what's going on. Let's move this slightly out of the way, so it's slightly easier to see. So we're going to do calculate mode, 1 minus 0.9827. So that's 0.0173. And this one here we're going to do now. That's 0.0468. Now, which of these two is closest to 0.025? Well, I think it's this one that's closest by quite a way. So we're going to be 0.0173 is the value we need. So it's the critical region is then identified as anything more than 10, but less than 25. So that's the second critical region. So the first critical region was this one, anything less than 1. The second critical region is anything more than or equal to 10. So I want you to give a picture in your mind about what's happening with this, just to give you a little bit of perspective, because it's important that you understand what's happening here with this two-tailed test. Most binomial distributions follow this sort of pattern. So if you sort of look at this as a sort of pattern, we're looking at this end and that end. In a two-tailed test, you're looking at what is out here and what is out here. So in this particular example, we had it being less than or equal to 1. So that would be defining the region here. And in the second part of the region was anything more than 10. So that would be the second part of the region here. And in here is what you would say H0 accepted. And out here are the two extreme values. That's where H0 would be rejected. So in the critical regions, these are the critical regions where H0 would be rejected. But in here, everything, you would accept the H0, but out here, you wouldn't. So anything more than 10, you would say you would reject H0, anything 1 or less, you'd reject H0, but in here, you're absolutely fine. Let's go back to the question. So the final part of the question does say, state the probability of it incorrectly rejecting H0. So a reminder about what these two probabilities were. I need to get the tables back up for this. So the probability of it being less than or equal to 1, as a reminder, was, struggling to see it, 0.0274. So just write that down. That was this one. And then this is the other critical region here. So the total probability of these two will be the probability of rejecting the hypothesis. So you add these two up and you will get 0.0447. That's 4.47%. So actually the significance level of this test is slightly better than 5%, slightly more rigorous. You're slightly sort of shortening it up. You were asked for a 5% level of significance, but actually you've actually got better than that. So in terms of 5% level of significance, we've actually done a bit better than that. We've got it down to 4.47, so that's pretty good. So hopefully that would be a good indication as to the evidence of risk that you are rejecting H0. Okay, let's trash my annotations and get into some other exercises. I particularly want to work my way through exercise 7D, because those particular questions are all two-tailed testing. So I'll just take a couple of seconds to get that set up. Right, so here's an exercise 7D. All this stuff is on page 109 of the textbook. I'd encourage you to have a go at these questions. I'm going to do 2 questions today, but you can have a go at the remainder. A warning again that the answers on the answer sheets are actually, some of them are incorrect, but the answers at the back of the book are correct for this particular exercise. We're going to look at number 8 first of all. A machine making glass bowls, and it's observed that 1 in 10 of the bowls have hairline cracks. Already we've got a probability, so 0.1. Production process modified, a sample of 20 bowls. So you can see where this is going already. Binomial distribution, 20, 0.1. Test at the 10% level of significance. What's going on? We do need to state the hypothesis. So proportion is going to be 0.1. Alternative hypothesis, it's not 0.1. And then we're looking at a 10% level of significance. That's 5% either end. So that's going to be 0.05 that we're focusing in on. And the 20, 0.1, we can read it from the tables where that's going to be. So we're looking at that particular idea. So let's pull up the tables once again. So to find the critical regions, you could look down the list and find those critical regions from the tables here. 20 is this distribution down here, and 0.1. But actually this question is slightly different, so we'd look normally at the critical regions in here. But actually this question doesn't require that too much, because actually all you're being asked to do is to test it against an outcome, because they're actually stating in the question that one of the bowls is already cracked. So one of them is already cracked. So all you've got to do here is look from the tables and see what is the probability of it being less than or equal to 1. So you look that up, and if that's less than 5%, you know you're going to be rejecting the null hypothesis. Let's have a look at that probability. So 0.1 is this column, it's down here. 0.3917 is the chance. So that is actually 39%. And you need it to be 5% or less. So actually, this is in the normal part of the zone. So going back to that previous diagram, this is the lower part, this is the critical region. This value is somewhere in here. So H0 is not rejected. There's not enough evidence at this stage to reject H0. Okay, you try to avoid saying H0 is accepted. You try to say H0 is not rejected. Slightly different terminology. It means the same thing actually, but to be honest, we try and say H0 not rejected. It's better terminology in terms of statistics. One more question to do, and that's question 10. So this is asking about a standard blood test able to diagnose a particular disease, probability 0.96. So we're going to be talking about whether that's changed. So my proportion will be 0.96, or whether it will be not 0.96. So again, looking at a two-tailed test. We're being asked to test it against 75 patients. So that's my binomial distribution, 75 patients, 0.96. We're being asked to test the probability of it's 63. So we're going to look up what 63 is in my table. Well, I can't in my tables actually, because this is not something you can look up in the tables. So rather than look this up in the tables, I'm going to need my calculator for this. So let's get our friend mode 7. This time I'm going to do a variable value. Variable, mode 2. I'm going to put in 63. X is 75. 0.96. I'm going to see what that value is. So this value here is 0.000417. Okay, very, very small. And we've got to test that at the level of significance, which I think in the question is 10%. Just double check that. So it's asking me to test it at 10%. So is this less than 5%? Well, absolutely it is. So again, going back to the previous diagrams I've been trying to show you. Two-tailed test in this case. This value here is way over here somewhere. It's really in the critical region. So we know that 63 is going to lie in this critical region, because the 5% is 5% because it's a two-tailed test. We know that this value is much, much less than 5%. So it's definitely going to be that H0 is rejected and the alternative hypothesis is accepted. The value has changed. Okay, that's questions 8 and 10 done for you on this exercise. I would encourage you to work your way through and do plenty of the other ones inside of exercise 7D in particular. All these questions are worth doing. I'd encourage you to look particularly at question 7, well worth doing, and question 9. just because they're exam type questions, and I think they'll really help you to understand what's going on with these particular questions. And I'd encourage you to have a go at those in your own time. As I said, please do look at the answer book, the textbook for your answers as opposed to the answer sheets, because the answer sheets are somewhat flawed for this particular exercises. So do make sure that you're doing that. Until the next time then, thank you very much for tuning in. I would appreciate it if you could leave me a like or subscribe, and I will hopefully see you again soon. Bye bye.